More with patterning. Problem 1. Helena created a table to look for a pattern in the given figures. Part A wants us to complete her table, B wants us to describe the pattern in words, and C wants us to create an algebraic rule or general term for the pattern. Now, lines are marked with a small dash so you know exactly where they are. And if we look at figure 1, we've got 1, 2, 3 sides. Figure 2, we have 1, 2, 3, 4, 5 sides. Figure 3, 1, 2, 3, 4, 5, 6, 7 sides. All of that's been recorded in the table down here. Now, if you look, the number of lines increases by, hopefully you've said 2, for each increase in figure number. So in figure 4, we should have, sorry about that, we should have 9 sides or lines, sorry. And in figure 5, we should have 11 lines. Figure 500, I have to keep adding 2 another 495 times. That's a lot of work. I don't want to do that. How can I get there without doing that? If I look, the difference between the number of lines increased by 2. So I'm adding 2 repeatedly. Now the shortcut for adding the same thing over and over and over again is multiplication. So I really have to look at 2 times the figure number. So in this case for figure 1, it's 2 times 1 plus something. Well, 2 times 2 plus something. 2 times 3 plus something. Hopefully you've realized that the something we add is in fact 1. So when I want figure 500, it's 2 times 500 plus 1, which gives me 1001. How do I write that as a pattern? The term number, term n, is 1 plus 2n, where n is the position number. So the value of the nth term will be double the position number plus 1. How did we determine the general term? We've already talked about that. The number of lines always increased by 2. And there's a typo here. I apologize. So that should say something plus, oh, no, it's not a typo. It's the way I wrote it. It's 2 times the position number plus something else. So if we multiply the position number by 2, the number of lines in each figure would be 2, 4, 6, 8, and 10. We need each of these numbers to increase by 1, and that's why we have the plus 1. If we look at the next problem, it shows 4 stages in the construction of a walkway. The walkway starts with a hexagon and continues with squares. So each shape has 1 hexagon. Shape 1 has no squares. Shape 2 has 1 square. Shape 3 has 2 squares. Shape 4 has 3 squares. If I look, shape 1 has 6 sides. I've added a square, and they have a common side that's not on the outside, so it's not included in the perimeter. So shape 2 has a perimeter of 1, 2, 3, 4, 5, 6, 7, 8 sides. Shape 4, if I count them up again, would have 10. And shape 4 would have 12 units in its perimeter. Now Ryan's pattern, he said, was 6. He started with 6 every time. Why? Hopefully you've realized it's because each of them has a hexagon with 6 sides. Now when you look at the next thing, he subtracted 1 from each of them. Why might he have done that? Well, when I look at shape 2, I have to take off the side that's shared with the square that's inside. This piece right here is inside. And then on shape 2, I added 3. Now, on shape 3, instead of just adding the 3, which I did for all of them that followed, I've added a 2. Why only 2? If I look at shape 3, I've got a common side here and a common side. So instead of adding 3 twice, I have to add 2 for my second one. And the same thing is going to actually hold right there. And you can copy this if you wish to. Each of the tables below shows the first 3 terms in a pattern, and we want to complete the table with it. Pause the video and try and complete the table before you move on. Hopefully you've realized that in the first table, the numbers are increasing by 2, so we can have a 13 and a 15 there. And they're increasing by 2, so it's going to be 2n as the general term. And do I have to add something or subtract something? If I do 2n for the first one, that's 2 plus something. 2n for the second one, 2 times 2 plus something is 9. 3 times 2 is 6 plus something is 11. Hopefully you've realized it's plus 5. In the second table, I'm not increasing by the same amount. I've got 1, 4, and 9. This one I have to work really hard and think because it's not an addition or a subtraction pattern. I'm actually following an exponential pattern. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and the last spot will be n squared. Finally, if I want to find the general rule for the number of tiles in the figures there, I want to think about the strategy I could use. I'm just looking for the total number of tiles. What strategy could I use? I could just keep going, draw the next few patterns, and do a table of values. And I'm going to leave that for you to work on your own.